All right, let's jump right into this explainer. If you've spent any time as a Linux sysadmin, you already know the sheer terror of the scenario we're going over today. It's a rite of passage, really. You've just finished up what was supposed to be a completely routine storage expansion. You know the drill. Added a new virtual disk, formatted the thing, mapped it out for an automatic mount, and then you issue a quick restart just to make sure everything comes up clean. Sounds incredibly simple, right? Well, that's when the unthinkable happens, and your system absolutely refuses to come back online. You hit reboot expecting a nice, clean start, but instead, your heart just drops. Your SSH session dies. The web services crash completely. And rather than getting that familiar login prompt we all love, your console decides to spit out this panic-inducing wall of text. And it always ends with those terrifying words, "Welcome to emergency mode." It's that gut-sinking moment when you realize a production server is totally stalled out. But don't panic. Today, we're going to break down the #1 reason servers fall into this trap, exactly how you read the logs to diagnose it, and most importantly, the exact rule you need to follow to prevent it from ever happening again. Now, as much as it feels like Linux is just trying to ruin your weekend, it's actually not doing this to torture you. This is emergency mode. It's a highly protective kernel mechanism. The system has encountered an issue that's so critical to its defined state that it basically says, hold on, if I keep booting right now, data corruption or major application failures are pretty much guaranteed. So it halts everything to prevent that corruption. It's literally just the operating system throwing up its hands and asking for a mechanic. So, how do we fix it? We take a deep breath and shift from panic to methodical troubleshooting. The system is actually handing us the instructions. Step 1, we just enter the root password. That unlocks the maintenance shell and gives us a command line to work with. Once we're dropped in there, we run our primary diagnostic command, journalctl-xb. The system literally suggested this command to us, and it acts as our direct window into whatever the kernel was experiencing the exact moment it decided to halt. Looking at a giant wall of system logs can be totally overwhelming, but those two little flags are an absolute lifesaver. It brilliantly illustrates how Linux filters out the noise. The -X flag brings in extra catalog information, which essentially adds explanatory, human-readable text to help us decode the errors. And the -B flag, that is absolutely crucial. It limits the output strictly to this current failed boot attempt, completely ignoring all the previous successful boots. You hit enter, scroll down, and just keep your eyes peeled for red text or failed dependencies. And paging through that output, bam, there it is, a huge block of angry red text telling us the kernel was looking for a specific hard drive partition that it just couldn't find. It literally says dependency failed for /mnt/data. It timed out waiting for a disk block device. The server couldn't locate the storage it was explicitly told it needed to function, which of course triggered that protective emergency mode we just talked about. Now, whenever you see this specific timeout error, it almost always points to exactly one culprit, the fstab file. This is the static file system configuration table, basically the instruction manual the kernel reads during the boot sequence to map and mount your drives automatically. Since the error is complaining that a specific drive failed to mount, we know for a fact we need to go look at the entry we just added to this file for our new data drive. Here's where the mystery gets solved. We jump into a separate window, run the blickhid command, and we get the actual universally unique identifier, the real UUID for our new disk partition. And, well, look what happens when we compare that string to what's inside our fstab file. Yep, when we copy-pasted the identifier, we accidentally deleted the very last alphanumeric character. Just a tiny slip of the keyboard and we completely butchered the UUID. So during boot, systemd tried to mount the drive, couldn't find that butchered identifier, and rightfully hit the emergency brake so the server wouldn't come up half broken. Luckily, the fix here is incredibly straightforward. Still sitting right there in our emergency shell, we essentially have two options. If you're in the middle of a massive, high-pressure outage, you can just slap a hashtag at the start of that line in the file. That comments it out, tells Linux to completely ignore the drive, and lets the server start normally so you can fix things later. But since we want to fix this permanently right now, we'll go with option 1. We just open the file with V, type in that missing character to fix the UUID, and save it. Okay, typo fixed. Now, you might be tempted to just blindly type reboot right away, but actually scratch that. That would be a massive mistake. You are playing Russian roulette with your production environment if you do that. This brings us to the absolute climax of this explainer, the non-negotiable golden rule of mounting. Never, ever reboot a server after editing the fstab file without testing it first. You need to run mount-a. This command tells the system to mount all file systems defined in the fstab file right now, immediately on the live system.
Why is this command such a game changer? Because it acts as a live fire test. If you made another typo, the system is going to scream an error right at you in your active terminal. And that is perfectly fine, because it's completely safe and easy to fix right there with zero downtime. But if it returns absolute silence, if you hit enter and it just gives you a fresh command prompt back, that means your file syntax is flawless. Skipping this step is basically buying a one-way ticket right back to emergency mode. We are always looking for absolute silence.
And because our mount-a test came back perfectly clean with that beautiful absolute silence, now we can confidently type our reboot command. Because we followed the golden rule, we get to sit back and watch the machine cycle effortlessly past that old error. It doesn't halt, no dependency failures, it boots up flawlessly, and we finally get our clean login prompt back. We are officially back in business, turning what looked like a terrifying server-ending outage into a super quick 10-minute fix. So while emergency mode looks like a total nightmare at first glance, remember that it's really just the operating system keeping your data safe. Treat your system logs as your treasure map. Always test your storage configurations by following the golden rule of mounting, and you will literally never have to fear a boot failure again. So what about you? Have you ever accidentally bricked a server with a bad entry? Drop your worst boot loop horror story in the comments below. Until next time, keep learning, and for the love of servers, always check your syntax.